Hey folks, this is Nick from First Coast Math Clinic, and this video is on how to factor trinomials when the value of a is not 1. So in this video, we're going to go through these 4 examples. Now I've made a couple additional videos on how to factor trinomials, and I made a specific video on factoring trinomials when a is not 1. I wanted to do another video where the value of a was a little bit more complex. So this is that video. I've included a link to the other videos that I made on factoring trinomials at the end of this video, so you guys can check that out. I've also included some timestamps at the bottom of this video, so if you want to jump to some specific examples, you can do that as well. All right, let's get into these examples. Okay, so example number 1 is 6x squared minus 11x minus 10, and our general form, ax squared plus bx plus c. We want to find our m value and our n value. We're not too worried about the signs right now. Let's just identify a, b, and c. So a is going to be 6, b is going to be negative 11, so we're going to include that minus sign with the 11. And c is going to be negative 10. So a is 6, b is negative 11, c is negative 10. And to find our values of m and n, let's draw our x, m here, n here, a times c, and b. So a times c is negative 60, b is negative 11, and I want two values that multiply to negative 60, but add to negative 11. So again, my advice is start with the multiplication, find values that multiply to negative 60, and then we could work on the addition, so, or even positive 60, and then you can kind of manipulate the signs. So the most obvious two are like 6 and 10, but there's no way we can kind of add 6 and 10 to get 11. So 6 and 10 aren't going to work. So let's think about maybe 15 and 4. All right, so 15 and 4 will multiply to 60, but I want them to multiply to negative 60, but add to negative 11. So one of them has to be negative. If I do negative 4 times negative 15, I'm going to get negative 60. But if I add negative 15 plus negative 4, I'm going to get positive 11. So that doesn't work. So let's change our signs. To negative 15 and positive 4. And if I do negative 15 plus positive 4, we get negative 11. So we get the combination that we want. And remember, when we're doing math, this is a little bit of what we have to do sometimes. We're not going to get the exact answer we want the first time. When we have to do a little bit of guess and check and try and see what, see if our result works and be okay with that. All right, so we've got negative 15 and 4. That's our m and our n value. So the negative 15 and 4, we're going to use that to replace our b value. So I've got 6x squared minus 15x plus 4x minus 10. And I know I could do this because if I take negative 15x plus 4x, I'm just going to get negative 11x, the original b value. And just looking at this, I know I'm going to factor this, so I'm going to actually switch this because I think it's going to be easier to factor the 6 and the 4 and the 15 and the 10. So I'm going to switch my grouping here. So again, in math, we try something, see if it works. So there's another way we could do it. We do it a different way. All right, so I was able to switch those. 6x squared plus 4x minus 15x minus 10. So now we can group our first two terms, last two terms, and we want to factor our binomials now. So 6x squared, that is 2 times 3 times x plus 2 times 2 times x. So what's our greatest common factor from here? That's going to be, we've got a 2, an x, and an x. So we can pull that 2 and the x out. And what do we have remaining? We've got a 3, an x, plus 2. So pulling from our parentheses, our binomial, we're going to pull a 2 and x, or 2x, and we're going to keep the 3x plus 2 in our parentheses. Now that helps us because we know that if we have a 3x plus 2 here, we have to have a 3x plus 2 here. So let's factor this second set of parentheses. I'm going to factor this into negative 5 times 3 times x minus 5 times 2, because negative 15 is negative 5 times 3 times x, and then this 10 we could factor into negative 5 times positive 2. So now what do we have in common that we could pull out? Well, we've got a minus 5 or negative 5 and negative 5, so we could pull that out. And what do we have remaining in the parentheses? We've got a 3x and then a positive 2, and that's our 3x plus 2 and 3x plus 2. So the minus 5 gets pulled out, and the 3x plus 2 stays in the parentheses, and now we're going to group our 2x and minus 5. And then we're going to group the 3x plus 2. And this is the answer for our factored trinomial 6x squared minus 11x minus 10. All right, let's get into example number 2. All right, number 2, we've got negative 8x squared minus 2x plus 3. So again, our general form, ax squared plus bx plus c. We want to find m. We want to find n. We've got a, b, and c. So a is going to be negative 8. B is going to be negative 2. C is going to be positive 3. So let's use that to find our value of m and n. So AC is here, B is here. Negative 8 times 3 is negative 24. We want two values that multiply to negative 24, and B is negative 2. We want two values that add to negative 2. So the obvious combination that I see, most obvious combination for m and n is 6 and 4. So if I want them to add to a negative 2 but multiply to negative 24, that would have to be negative 4, or should be negative 6 and positive 4. All right, so that's going to be my combination. M is negative 6 and n is positive 4. So now I can substitute those values. I can replace my b value with negative 6 and 4. So we write 8x squared minus 6x plus 4x plus 3. And when we factor this, let's see, do I want to factor it this way? Yeah, let's keep it like this. So put my parentheses around the first two terms, last two terms. So I can break this up into maybe negative 2 times 4 times x, and then minus 2 times 3 times x. And so what's our GCF here? Well, we've got a -2 and a -2, and we've got an x and an x, so we can pull those values out. And what do we have remaining? Well, we've got a 4x and a +3. So I'm going to pull out the -2x, and then we've got a 4x, and this is going to be a positive because I'm pulling out the -2. So this is going to be a +3. All right, so that is this value here. Now, if you look at the second set of parentheses, well, we've already got that here. So we really don't have to do any factoring here. We already have 4x plus 3. So the only thing we could really pull out is just a +1, right? Because we could divide this by +1 and not make a difference. So now let's group terms outside our parentheses and inside, and we're going to rewrite this as -2x plus 1, 4x plus 3, and these are our factored binomials. All right, let's get into example number 3. All right, so for number 3, we've got 3x squared plus 14x plus 8, and our general form we know is ax squared plus bx plus c, finding m, and we're finding n. So we're looking for a, b, and c. So our a value is going to be 3, b is going to be 14, c is going to be 8. So let's fill in our values, 3, 14, and 8. Let's find m and n. So I want AC here and b here. So a times c is 24. And I want two values that multiply to AC. B is 14. I want two values that add to 14. This is m, this is n. So based on the previous example where we had like 6 and 4, two obvious values that will multiply to 24, but those values aren't going to add to 14. So we've got to try some different values. We're just going to do some guess and check. So 6 and 4 aren't going to work. So what about maybe 2 and 14? Actually, excuse me, not 2 and 14, 2 and 12. So 2 times 12 gives us 24. 2 plus 12 gives us 14. So we can use 2 and 12 as m and n. Keep writing 14, should be 12. And that's another side point. Make sure that as you're writing this, you're not making any small mistakes like that. You're writing the correct values, 2 and 2, 12 and 12. So now we can replace our value here. We can replace that middle value with 2 and 12. So we'll do 3x squared plus, and I'm going to put the 12x here, plus 2x plus 8. Now we'll group first two terms, last two terms, and we want to factor our GCF, our greatest common factor, from each set of binomials. So I can rewrite this. This is going to be 3 times x plus 3 times 4 times x. So what's our greatest common factor here? Well, we've got a 3 and an x and a 3 and an x. And what do we have left? Well, we've got an x plus y, right? So we can factor out the 3x, and we're left with x plus 4. I think I said x plus y, x plus 4 inside the parentheses. So x plus 4 should stay in the parentheses. and 3x is our GCF, right? And the advantage to doing this is we know that we should have an x plus 4 here in that second set of parentheses. So let's factor 2x plus 8. So I know this is just 2 times x plus 2 times 4. 8 is 2 times 4. So what's our GCF? Well, I can factor out a 2 and a 2. So I'll put that 2 right here. And what do we have left? Well, that's our x plus 4, all right? So that gives us our answer. We can group together the terms outside the parentheses and the terms inside the parentheses. So our answer is going to be 3x plus 2 times x plus 4, and that's our factored binomials for the trinomial 3x squared plus 14x plus 8. All right, let's do one more example. So here we've got negative 5x squared plus 8x minus 3. So ax squared plus bx plus c. We're looking for m, and we're looking for n. So a is negative 5, b is 8, c is negative 3. I want AC up top and b here. Negative 5 times negative 3 is going to give us positive 15. And I want two values that multiply to positive 15. B is positive 8. I want two values that add to positive 8. So for our m and n values, we could use 5 and 3. So those will multiply, 5 and 3 will multiply to 15, but add to 8. So we can replace that middle value with 5 and 3. So I'll rewrite this as negative 5x squared plus 5x plus 3x minus 3. And again, I decided, you can switch these if you want, but I decided to put the 5 here and the 3 here because I know when I group this together, I'm looking for my GCF, and I'm going to have a 5 and a 5, so I could just pull that 5 out. I'm going to have a 3 and a 3, so I could just pull the 3 out. Okay, so that's why I'm choosing to group this as I did. So now, when we're finding our GCF, well, we know that this is basically just. So we can rewrite this as, make this negative 1 times 5 times x plus 5 times x. And I'm pulling out the negative 1 and the 5 because I have opposite signs here, right? This is a negative, this is a positive. So I want to account for that. So I'm pulling out a negative 1 times a 5. So now my GCF, my greatest common factor, is going to be the 5x and 5x. And actually, to make this a little bit clearer, we can even do like a times 1 here. So now what I've got left over is negative 1 times x plus 1. So that's going to stay inside the parentheses. I'm going to pull out a 5x, and inside the parentheses is negative 1x plus 1. So I know in my second set of parentheses, I should have the same thing, negative 1x plus 1. So how do we get that? Let's figure out how we can factor out this second set of parentheses and get negative 1x plus 1. Well, positive 3, well, I can factor that into negative 1 times negative 3, because negative 1 times negative 3 is positive 3 times x. And then minus 3 times 1, right? Because I can multiply anything by 1 and just get itself back. So now, what can we pull from this? What do we have in common? Well, we've got a negative 3 and a negative 3 that we can pull out and put right here. And what do we have left inside the parentheses? Well, we've got a negative x, and then a positive 1, and that's our negative x plus 1. Okay, so now let's group our terms in front of the parentheses or outside the parentheses, and our terms inside the parentheses. So we're going to get 5x minus 3, and then negative 1x plus 1, and that's our factored binomials for the trinomial negative 5x squared plus 8x minus 3. All right. All right, so these were 4 examples on how to factor trinomials when the value of a is not 1. I decided to make the value of a little bit more challenging on these examples. Hope these videos are helping you guys. If you like these videos, leave a like, comment, and subscribe. Check out the video that's going to come up next. It's on some additional examples on factoring trinomials. So again, check that out. This is Nick from First Coast Math Clinic.